Well, theorem 13.3, equality of mixed partial derivatives. If f is a function of x and y such that the mixed second partial derivative and the mixed second partial derivative f of xy and f of yx are continuous on an open disk R, then f of xy equals f of yx at every point xy in that open disk R. And so if you look at functions that are generally continuous, that would be kind of nice. Say most of the time that's going to be true. So let's look at an example.
Engage.
Okay, so we will engage. If f of xy equals e to the x plus x times the ln of y plus y times the ln of x, find all four second partial derivatives. Well, the first thing we have to do is find the first partial derivative, so find the derivative of this function with respect to x. The derivative of e to the x is e to the x. The derivative of x times the ln of y would be a constant, so it's just going to be ln of y. The derivative of y times the ln of x, here y would be a constant, and so the derivative of ln of x is 1 over x, so we just have y over x, and this is the first partial with respect to x. Here's the partial with respect to y. Derivative of e to the x would be the derivative of a constant with respect to y, so that's 0. The derivative of x times the ln of y is going to be x divided by y, because x is a constant and derivative of y is 1 over y, so there's that part. And the derivative of y times the ln of x, well, the derivative of y is 1 and ln of x is a constant, so it's just plus ln of x. Find the derivative of the second partial of this function. We'd take the derivative with respect to x and then differentiate that again with respect to x. The derivative of e to the x is again e to the x. The derivative of y over x is y times the derivative of 1 over x, which is negative 1 over x squared. So I think you could probably see that pretty quickly. Similar fashion, the derivative of this one with respect to y is negative x over y squared plus 0, so negative x over y squared. And now to check our theorem to see if the mixed partials are equal to each other, we could try that. If you said, what's the derivative of this function with respect to y, it would be 1 over y plus 1 over x. There it is. And if you took the derivative of this function with respect to x, it would be 1 over y plus 1 over x. So there they are, the mixed partials are the same, just as we expected they would be.
Make it so, number one.
And it is so.